In today's ChemTask, we're going to look at matter through Ant-Man's point of view. Every single physical thing in this beautiful world that we live in, as chemists, we call matter. And inside of matter are these little tiny things that are called particles. And what makes the different type of matter different are how these particles are arranged. But guess what? We can't even see these particles. But Ant-Man can. So today, we're going to learn exactly how particle diagrams are drawn, written, and how to read them. So what does Ant-Man see? He sees particle diagrams. And a particle diagram is an illustration that represents the arrangement of particles that make up that type of matter. Meaning that we have all different types of matter, we have different types of particle diagrams. So particle diagrams are representations of the different types of matter that we have that show the arrangements of the particles inside of what is usually boxes, but sometimes could be circles or even the outlines of the objects that we're talking about. So in the particle diagrams that represent atoms, we have single spheres that have the same size and color that represent atoms of the same element. Particle diagrams of molecules, we have two or more spheres that are joined together. They can be the same color, but they don't have to be the same color. But if we have two or more spheres joined together, they are considered molecules. Molecules of elements. And when we have molecules of elements, we will have a bunch of particle arrangements inside of the box that all have two or more spheres of the same size and color. This is how we know they are from the same element. We also have particle diagrams that are of molecules of compounds. And when we have these particle diagrams, we will have all of the particle arrangements inside of the box that have two or more spheres of different size or colors joined together. But as you can see, all of the molecules inside of this particle diagram are exactly the same. They all have one orange, one blue, and one black sphere. We also have particle diagrams of mixtures. And being that we have two different types of mixtures, homogeneous, in which everything looks the same, and heterogeneous, in which we can visually see the differences inside of the mixture, we're going to have all of the spheres, the molecules, with different arrangements together, but not joined. So in our homogeneous mixture, black particles are scattered all throughout, randomly distributed throughout the mixture. In the heterogeneous mixture, the black spheres are clustered together. They are grouped together, showing us the visual difference within the mixture. And finally, we have particle diagrams of the different phases of matter, the states of matter. We have solid particle diagrams in which the particles are all grouped tightly close together in the shape of the actual solid. Then we have liquid particle diagrams in which the liquid particles are at the bottom of the container, representing where the liquid would be. They're spaced a little bit farther apart, but they are not spaced as far apart as where the gas particle diagrams would represent, how the gas particles are all scattered throughout the entire particle diagram.
Draw a particle diagram of a mixture of salt water evaporating.
So for this ChemTask, I have to draw a particle diagram of a mixture of salt water evaporating. To do so, I have to draw my box. The next step is to draw my liquid salt water. So to do so, I'm going to start off with my water, and I know it's a liquid. So all of my particles, I'm going to make them blue, are going to be down at the bottom of the container. And they are also going to be spaced apart to represent the spacing of these liquid particles. I have all of my water particles at the bottom of the box to represent them being a liquid. Now I'm going to make it a mixture by adding the salt. And for it to be a salt water mixture, I know it's homogeneous. I cannot see the salt in the water, so the salt particles are going to be randomly distributed throughout the water particles. I'm going to show that there are some liquid water particles turning into gas water particles, steam. And to do so, I could just draw some blue liquid particles scattered throughout. At the top of the container, filling the box to show that they are gas particles. And this is a particle diagram of a mixture of salt water evaporating. That's your ChemTask, everyone. That's how you draw particle diagrams. That's how Ant-Man sees it. That's how we're going to draw it.